Kirtana, can you hear me?
Yes, sir.
All right, Kirtana. So, what is the last topic we discussed?
About powers.
Wow, thermal energy. The thermal effects of current. Heat dissipation in resistance, power supplied and absorbed. We have already done. Okay. Do we have discussed about heat dissipated in resistance? Yes, I think we have already discussed it. So yeah, Kirtana, like this thing is very simple to use. The last thing, um, okay, people register is also same. All right, I think we can start with the problem solving part. This- Okay, Kirtana. So today we'll discuss about a maximum power theorem. Maximum power. This is one of the very important topic. Maximum power theorem. Maximum power transfer theorem. Uh, it is connected with like there's a circuit which is connected with a resistance, and this is connected with a battery. This and this is the current condition. This is R and this is V. So you can see, kids, now this is a whole part of the battery. This is a part of a battery, and this is your internal resistance, right? So if I ask you, Kirtana, what is the current in the circuit? So you will say, sir, there's a current I and there's a current I. So Kirtana, can you tell me the value of current? Circuit current? Kirtana, what will be the circuit current in this circuit? Kirtana, what will be the value of circuit current? Please let me know first.
Yes.
How much?
Yes.
No, incorrect. Think again. Kirtana, please.
Is smaller plus capital.
No, what is the proper value? Just give me the proper value of current, okay? Just look at the circuit. Whatever the values you have given on the basis of whatever the variables you have given on the basis of get me the value of current.
E into smaller plus capitalized.
Again, what is the formula for current? What is the current formula, Kirtana?
Yes.
VR. Okay. I had never seen a formula there. I have never seen something like this. You know what? I have never seen something like this in my life. I have seen something like this. Never this. I don't know from where you get this formula. From where you got this formula. Be careful. This is a very basic thing, Kirtana. What I can say at this particular point. You couldn't remember this small formula. The fundamental grade 10th formula. Okay. Even if I don't, I'm not taking your class for this chapter. No? Even if I didn't taught you this chapter, you should remember this formula from grade 10th. Okay. Yeah. So I is equals to what is V? E. What is
Yeah.
R? R plus C. So this is the total current, right? What? Yeah. So if I ask you power across this resistance, so you will say the power is nothing but E by R plus small r into R. So this is basically power transferred to external resistance, right? So kids, now look, what I wanted to do is, sorry, it should be E into this, and with respect there was E, so it will be square. Yeah, kid. So what I wanted to do is, I wanted my total portion of the power. I wanted maximum power to be consumed by this resistor. But how I should do it? I really don't know whether this will consume a maximum power or not. So what I can do is, this is an internal resistance. I can't really do anything with this. Okay, the only thing I can change is the resistance. I wanted a value of external resistance REX such that it can consume maximum possible power from a battery. Okay, if the internal resistance is R, it should be able to consume maximum power. So what I should do? Let's do one thing. Let's differentiate this with respect to R. Is that clear?
Yes.
Okay. So in another decade, what I can simply say is, let's not go with the differentiation way. It might be not that feasible if you're not good with differentiation thing. Okay. So if I ask what is the power supplied, so you can simply say, sir, the battery is there, and from battery the current is going EI, right? Current is going there. So this is the power supplied by the battery. What is the consumed by the resistor? That is I square R, right? So the power supplied you can call it as, how much is the power supplied? EI minus I square R. Okay, I square R. Why this I square small r, not the capital R? Because this is the total value this battery has. Okay, out of the total value, because there's a small resistance I, it is also having current. It is also consuming some amount of power. So out of the total value, this small amount of the power is consumed by its internal resistance itself, right? So you are only left with this thing. Okay. So whatever the left is, that is supplied to this thing, right? If I just make a equation for this, if I just make a equation for I, power versus R, if I make a circuit equation, something like, you can say this is power supply, okay, is equals to EI minus I square small r, right? So yeah, you will be having something like 1 E by E square, here it will be R divided by R plus small r, okay, and here again we are going to get is minus maybe E square R square divided by R plus R. This is what you are going to get. Something like this. Okay. Maybe. So if I ask you what kind of circuit it is going to be, so if you make a graph of P versus R, you will be getting something like this. This is the maximum value of power which you can ever have. So what is the condition for this particular point? The top point. This is R, and this is changing the value of R. Okay. You can say this is a point P max. I wanted to calculate this P max, but how I should calculate? Let's do one thing. I know this thing, right? So what I can simply do is dP by dr. Because my R is variable. Power is getting varied because you can see, because this is a constant, this E is constant. What is varying? This R. So I can say this dependency is there, right? So if you differentiate it, what you are going to get is Okay. Yeah. Basically, if you take this thing now, so let's differentiate this part itself because this has just two components. Right? So we'll be taking this part to be to differentiate. So I'll just take it down. What is the value of power? That is E square capital R divided by R plus. This is what we are going to differentiate. So if you differentiate this thing, what you are going to get is the small, basically what formula you are going to get? V square no, U dV by dt minus, okay, I don't know if you could remember this formula or not, but yeah, we have to use this formula for differentiation. So that will come out as R plus a small r. Okay, this R is itself, so at the top it will be as it is. You can keep as it is. So minus R, and if you differentiate this thing at the bottom part, uh, so it should be slash, and it's honest. Yeah, so it will come out as 2R plus R. Okay, divided by R plus R because already one square was there and another square, so that comes out as 4. Okay. That is one thing, and you can see R plus R is a very common one, so you can say that this thing will common, this will common, it will make it exist. So what are getting this thing minus R times of 2, which is equals to 0 because the whole bottom is 0. So if you keep the whole thing is equals to 0, you will get the value of R is equals to R. Okay. If you just do this thing, you are going to get R is equals to small r. It means when your R value is equals to basically when your external resistance equals to internal resistance, then the power consumed by external is maximum. Okay, this is a condition for external resistance to have maximum power, maximum its resistance should be equals to internal resistance. This is one thing. Any doubt here?
No, sir.
And this is called the power transfer theorem. Okay. Ketan, I'm just giving you one circuit. Solve this problem. Get me the answer. Whatever the theorem we have used, maybe we can use it. Maybe we may be using the knowledge we have gathered earlier itself. So, like every direction we are looking, not just in one direction. So this is the problem. Try to solve it and get me the answer first.
So what does that arrow on the register indicate?
What happened, Kirtana?
The arrow on the register, what is it?
Wait. What happened?
The arrow on the register, what does it indicate?
This arrow dial. This is basically variable resistance, and you have to figure out the value for this one. Okay, on the basis of given condition.
Okay.
Kirtan, have you solved it or not? Hello, Kirtan, are you there?
Solving.
Solving, how much time will it take for this one? Won't give more than 2 minutes now, okay? Just 2 minutes.
So 1.3, sir.
Yeah, Kirtan, what is the maximum, what is the value you have got?
1.3.
How 1.3? It's incorrect, Kirtan. It's completely incorrect. Look, Kirtan, I don't know. Look, you are given this kind of circuit and they are saying give me the maximum power. Maximum power condition is what? Just look at the variable. This is the only variable, right? So I can say, because you wanted to have maximum power, so it means, can I say that this resistance should be equals to whatever the resistance is across this much? If this is the condition, then basically whatever the resistance is across these and these two terminals, if that comes out equals to this one, I can say that the condition will satisfy for the maximum power theorem. Can I say this statement?
Yes.
Okay. So how can we solve this problem? I can simply say that, just look at this. 20, this is 4, this is again this, and this is 10. This is basically 5. 5, okay, and this is something. Now, I wanted to ask you what is the resistance across these two terminals, right? So you can say this is 4, this is 6, this is 20, and this is how much is 10. How you can calculate the resistance across this? Look at this case. Now, these two resistors are a parallel, okay, and all these two resistors are in the series with this, right? So can I say the total resistance will be nothing but 4 parallel 6 into series with 5? Can I say this? So what's the problem in this? You can simply go and say this 6 plus 5 as a total resistance, which will come out as something around 24 by 10, 2.4, 7.4. This is the Kirtana resistance across these two terms, okay? Across AB. Let's say this is A, this is B. So resistance across A and B is equals to 7.4. For maximum power theorem, for maximum power, R should be equals to REB, and that comes out as 7.4. That's it. Okay. Any doubt? Kirtan, any doubt is there? Please let me know first.
No, sir.
Alright, right. Okay. One more problem I'm sharing. You can try this one actually. It's a good problem. Kirtan, solve it fast. Get me the answer. Look, the concept of maximum power theorem is, let's say this is a battery, okay, and this is one resistance, this is another resistor, right? Assume if you both are given to you with a fixed value, so you can't do anything. But if you are saying that this is a variable and you know the data about this, so what should be the value for this one so that you have maximum power? It can only be possible if both have a same resistance, okay? Something related to this you can think of.
So can I solve this?
Okay, Kirtana. So what is the condition you are given here? In a battery, like if you are given a battery grid having n cells in series and n rods in parallel, right? This is the condition I think given, right? What is given? You are given a battery grid which is made by 24 cells having 1 ohm resistance which can deliver maximum power of a load. That is the condition I mean, right? So if you could remember a condition where I talked about if you are given n batteries in parallel, okay, and this is a basically m times of the same thing is going on m times. So what is the net equivalent resistance you get in these conditions? N times of E. Okay, this is what you get. Okay, and R equivalent in that condition you get as Nx by M. Basically, whatever the resistance is there for one and M by M. This is what you get in that condition. So here, what is given to me? Here they are saying, if I ask you how to calculate total number of cells, so you can simply see I have n cells here, m cells here. What is the total cell? N into m. So here also they are given n into m. Total cell is given as 24. And what is it? N into m. Okay. My task is how I should apply because they are saying how a battery grid can be made. So I really don't know like what should be n, what should be m. I have a calculator, right? So yeah, one more thing, which can deliver maximum power, okay, to a load resistance 10. So can I say, Kirtana, they have given me a basic data like what should the value of cell I should keep. So yeah, basically this whole thing is a grid. This whole thing is grid. If okay, if the net resistance of something is let's say Rg, this is the grid. If you connect this thing with an external other resistance of 10 volt, okay, then you are getting the maximum power. So I can simply say, Krishna, this and this resistance are same. And what is the resistance of the grid? You have already seen Nx by M. And what is X? That is one cell. That is 1 divided by M. I don't know. I really don't know. But yeah, for maximum power, they both should be equal. So you can say this value is given to me as 10. So you can see, Krishna, I have calculated the relation this, right? So again, I really don't know what is the value of M. So what I should do, Krishna, here? I just have this idea, right? I just have this idea. So, like, what I should really do? Let's say, Kirtana, if my m is equals to 1, if my m is give value 1, then I will say my n is equals to 10. Then equivalent resistance will come out, equivalent will come out as 10 into E because you can say that this is the condition, right? This is the given condition form. Okay. So, what I'm going to get in that case? Sorry, just a second, I have made mistake, I think so. Yeah, n into m was 24, right? Okay. So n into m is 24. So if you keep m is equals to 1, you will be getting n as 24. So this is 24. So what is E equivalent? You can say that n times of E. So this will come out as 24 times of the E value. Okay. And R equivalent is itself given as 24 resistance. Why it is 24 resistance? Because R equivalent is n 1 by m, basically n by m. So 24 by 1 comes out as 24 itself. Okay. So power what you are going to get in this case, that will be 24 e v square basically divided by r. Okay. Yeah, I said the total grid should have 10 value, right? So that's why we are taking this as a grid thing. So I'm saying this is going to give you the current. So let's remove it. 24. Okay. This is the current, basically the total thing, and it should be equals to 10. So what the power you can get? 4.9 E square. We really don't know the value, what's the value of E right now. We can keep it as it is. If your M is 2, so you can solve it further also, like M will come out 12, it will be 12E, and R equivalent will be again 12. It will actually 5 point, it should be 6, right? Yeah, it will be 6. Why it is 6? N by M, right? What is N? That is 2, 12 by 2. So that becomes 6. So what is the power you are going to get? 12e by 6 square is equals to 10. So you can say that this is going to be as how much? 2 square, 4e square and 40, 2, 4e square is equals to 40. So from here you should be getting 5.62, will it be 5.62 or something else? No, I don't calculate it again. 6 to 12 is, yeah, I think it will be 5.6 something. I'm not exact, I really don't know what's the exact value, yeah, but this is the value. Okay. So you can say that Kirtana we have did it for the two values, right? Okay. So can I really go more than m is equals to 2? Let's see. If you see carefully, n into m should be equals to how much? 24, right? This is a condition given to me. And I have already got that n can be maximum as 10m. So I can write it as 10m square is equals to 24. So m can be at max 24 by 10 under root. So if you just solve it, you will be getting as 2.4, okay, under root. Is this clear, Kirtan?
Yes, sir.
This will come out as 1.55. So for max case, you can say that I can really go till n. This is the maximum case, okay, because I really don't have these many values. Okay, I can't go more than this. So this is the condition. That's why we are taking only till n. You can see this. Is this clear, Krishna?
Yes, sir.
Any doubt? Any doubt?
No, sir.
No. Okay. So I think I can move to the next last problem. Okay, this is the last problem. Yeah, Krishna. This is the last problem I think we will be doing for this topic. So yeah, this is the last topic. After this, we will in the next class might be taking a different topic, not this one. So you can try to solve this. Get me the answer. Time I will give only 2 minutes because the session is not. Or okay, you can take All right, Kinna, should I give the solution for this one? Okay, Kinna, do one thing, take it as your homework, okay? Here, try, take it as a homework. I won't give the solution for this one, just do it as a homework part, okay? So yeah, that's all for the today's class, Kirtana. Any doubt if you have, just let me know. Otherwise, we can end the session. You can try this as a homework part.
Okay, sir.
Um, okay? All right.